Hi, this is Keshav of CSC Data Science. Today our topic was loaders and linkers. Object program contains the information, translated instructions and data values, addresses where these items are to be loaded. Three things to do executing object platforms: loading, relocation, linking. So loader or linker. Object programs are some no matter whether generated from the assembler or compiler. For simplicity, just call loader. For loader, linker or both. As same presentation steps and similar examples as previous chapter. Basic functions, machine dependent features, typical machine independent features, design options, implementation examples. Basic functions, absolute loader. Things a loader to do: check header record, read text records and put the proper memory locations. When end record is encountered, jump to start. In object program, each byte is in two characters. For example, 14 is two characters, 1 and 4, but needs to be converted to 14. 31, 30 to 1, 34 to 30 to 4. And then 1 and 4 are combined to form a byte 14. Of course, object program can be stored in a binary form. Two issues to remember: may not be readable by people, may conflict with the same control codes. No relocation and linking functions. When a computer first starts or turns on Bootstrap Loader, a very short program in ROM with a specific address such as 0, automatically run from the addresses. Load OS at the specific addresses such as 80 and jump to 80 to execute OS after finishing loading. Or a hardware initiator reading of a record of the Bootstrap Loader which reads at the next record. Read the following code such as OS or a standard load program that can run without OS. Go through the program carefully and line by line. No error check here. Machine dependent features: relocatable program loader. Multiple programs sharing memory requires relocatable. Library functions also require relocatable. Have relocation and linking capability. Relocation and linking are close related, so discuss together. In particular, linking requires relocation of subroutines linked together. Program relocation, modification record. A perfect way to implement relocation. Just add a start address to the loaded program in the instruction indicated by each modification record. If without relative addressing, most instructions need to modification record. For each word in object program, there is a relocation bit indicating whether it reads relocation. Collection of the relocation hits from the relocation mask. Word alignment because of the mask. The fourth text record has less than 12 words, i.e. 10 words. Hardware relocation. For relative addressing, hardware will automatically add an offset in instruction with the some segment registered during program execution. However, the linking makes it necessary for the loader to do the relocation. Program linking. External definition and the reference. Define a record and refer record. Three control sections. Same set of the references to external symbols. 3 in the instructions and 5 are data words. First reference to Lista in ref1. In program, not external, so assembled as the normal PC relative. In ProGB, Lista is external, so address is set to the 0 and a modification record is created. Second reference in Proga, prog A and prog C as well. List B is external, so 4 is stored in the address field and the modification record is created, but in prog B it is local. Third reference to end A to list A. In prog A, the immediate value is computed and put in the instruction prog B and prog C as well. Both end A and list A are external, so the two modification records are generated. Program linking. A program in memory after loading and linking. Prog A is starting at the 4000, ref 4 and ref 8 have the same values in all three programs. However, for references that are operands in the instructions, the results are not always same. Example, 1D for reference 1, prog A and 4040 for the reference are in prog B. Algorithms and data structures for linking loader. Modification record. Make a liking and relocation to be processed similarly. Two passes align same addresses to the external symbols, perform actual loading and relocation and linking. The data structures used by the linking loaders. External symbol tab, name, address and the control session belonging to the also control session's name, address, length, hash table. Stay B with the control sessions and external symbols. Program load address prog A DDR. The beginning address in the memory where the linked program is to be loaded. Supplied to the loader by OS. Control session address CSA DDR. Starting address of the current control session added to all relative addresses in the control session to get an actual address. Execution starting address EXEC Algorithms for data structures for linking loaded. Continue. In pass 1, just a process header and the defined words Pro prog ADDR is initialized from the OS, also becoming the starting address of the first control session. Control session is entered ESTA with the name and the header record address on the CSA DDR for each symbol in the defined record. Enter to ESTA with the name address value in the defined record. When end record is encountered, CSLDH is added to CSA DDR, which become CSA DDR to the next control session. Machine dependent features. Automatic library search. Loader and linking is generally considered as OS features. Standard libraries such as mathematical or statistics by default or by the parameters to allow the multiple libraries to be in the linked form. So search the libraries containing the external definitions of these symbols and fetch the code to the link. If still undefined symbols, errors are reported. The above process allows to override the standard subroutines in the library. Directory of the symbols in the libraries are to accelerate the search external references. Same for the external references to data items if any. Machine dependent features loader options, parameters. These are some of the parameters which are machine dependent independent loaders options. Loader design options, dynamic linking, implementation examples, MS-DOS linker, implementation examples, Sun OS linkers. Implementation examples: Cray Map Linker. Recall. Parallel architecture consisting of a large of interconnected processing elements (PE) share programs and data. When loaded, each PE gets a copy of executable, its private data, and its portion of the shared data. Each PE can access the memory in all other PEs, but the access is faster to its local memory. Parallel processing or programming. Thank you.